Input is required to continue when the interaction icon appears in the lower left-hand corner of the screen. Servos provide more precise movement by rotating an object to a specific position. Servos are found in a variety of everyday devices, including remote-controlled cars with steering, CD/DVD players that extend or retract disc trays, animatronic puppets in movies, and throttle control to adjust a car's speed. The servo rotates its shaft to a set angular position between 0 and 120 degrees. Once its position has been set, the servo continually draws power to maintain that position until another position is specified. You will have an opportunity to use a servo with the PLTW activities. Servos are most commonly used to create controlled movements based on programmed behaviors. A servo can be plugged into any of the motor ports on the Cortex. Now let's launch the Robot C software for VEX Robotics. Once the software is loaded, you will need to open the PLTW template file, select Skip to bypass these instructions. Use the PLTW template file to create any new program. Enter general program information, then save the file as yourlastname_servo. Open the Motors and Sensors Setup window. First, select Robot. Then select Motors and Sensors Setup. On the Motors tab, set up port 9 with the name Servo Motor. In the Type drop-down box, select 3-wire servo. Click OK to save the setup and close the window. Notice that the pragma statements at the top of the program have now been automatically inserted to reflect your changes. To test the motor setup, select Robot, then Compile and download program. In the Motors with PID debugger window, change the value in the power column next to the servo motor to 63 and verify that the servo rotates. Then change the power value to -127. Finally, change the power value back to 0. Now that the motor configuration is verified, let's set up the program that will tell the robot what to do and how to react to its environment. For the servo program, let's have the servo go to position -127 for 5 seconds, position 0 for 5 seconds, and position 127 for 5 seconds. Let's identify this as the program's task description. Now let's create the program's pseudocode. We will consider complex behaviors first, then simple, and finally basic behaviors. The task description is already at the simple behavior level, so let's break the behavior down into basic statements. The behavior can be broken down with this pseudocode. Now let's write the program based on the pseudocode. Task main marks the beginning of the program. Your entire program must be contained between the curly braces. Let's begin by expanding the natural language library in the text functions window. In this instance, we'll need the movement and weight libraries. Drag the first command set servo directly under the open curly braces. Define the statement's parameters as servo motor and -127. Insert a comment on the same line using 2 forward slashes and the statement servo to position -127. Drag the command wait onto the next line of the program. Define the statement's parameter as 5. This will specify the number of seconds the servo should hold that position. Insert a comment describing this behavior. Drag the command set servo onto the next line of the program. Define the statement's parameters as servo motor and 0. Insert a comment describing this behavior. Drag the command wait onto the next line of the program. Define the statement's parameter as 5. Insert a comment describing this behavior. Drag the command set servo onto the next line of the program. Define the statement's parameters as servo motor and 127. Insert a comment describing this behavior. Drag the command wait onto the next line of the program. Define the statement's parameter as 5. Insert a comment describing this behavior. Verify that the program aligns with the pseudocode. Now compile the finished program and check it for errors. Select Start to run the program. Any program errors or warnings will be displayed in the Errors window. A red or yellow X appears on the line number of any statement containing an error. The message will describe the error. A common error is a missing semicolon at the end of a statement. This concludes the PLTW instructional resource on servo and wait commands.